Hello everyone, today's topic is complex exponential function. So we know that e to the power z is equals to e to the power x plus iy because z is equals to x plus iy. Now this is equals to e to the power x into e to the power iy. Okay. Now e to the power x will remain as it is, and e to the power iy can be written as cos y plus I sin y. Okay, so now Ez is equals to Ex into cos y plus I sin y. So Ez is equals to Ex whole into cos y plus I sin y. This is called the complex exponential function. Okay, so now let us see some questions based upon this topic. So the first question is, find the value of the complex exponential function z is equals to 0. So when z is equals to 0, that means x plus iy is equals to 0. Okay, so here e to the power z is equals to e to the power 0. Okay, now that is equals to e to the power 0. In place of x we are going to put 0, and in place of y also we are going to use 0, so plus I sin 0. Now we know that e to the power 0 is equals to 1 and cos 0 is also equals to 1 plus I sin 0 is 0, so its value is 1. Okay, now next question is, now see, the next question is z is equals to I. So we know that z is equals to x plus iy, and this is equals to 0 plus I. Okay, so now so e to the power z is equals to e to the power x plus cos y plus I sin y. Okay, so here we know that e to the power z is equals to, here we know that x is equals to 0, so this is e to the power 0 whole into y is 1. Okay, cos 1 plus I sin 1. Now we know that e to the power 0 is 1, so 1 into cos 1 plus I sin 1. Alright, now see, cos 1 value is 0.5403 and sin 1's value is 0.8415. So this is the final answer. Alright, now the next question is, z is equals to 2 plus pi I. So here x is equals to 2 and y is equals to pi. Alright, so now e to the power z is equals to e to the power x, that is e to the power 2 whole into cos y, that is cos pi, plus I sin y, that is I sin pi. Alright, so now we know that sin pi is equals to 0 and cos pi is equals to minus 1, so this is equals to e square whole into minus 1 plus 0. Okay, so its final answer is going to be minus e square. Alright, okay, so our next topic is logarithmic function. So if e to the power w is equals to z, then when we apply log both the sides, then it will be log e to the power w is equals to, so now log ew is equals to log z. Okay, so we know that z is equals to x plus iy. Alright, so here this reduces to w is equals to log z and w is equals to u plus iv. Fine. Now let us find the value of log z. So log z is equals to log of x plus iy. Alright, now this can also be written as log of z. This one can also be written as r into e to the power I theta. Okay, now this is equals to, see here, let me write z is equals to r into e to the power I theta. Fine. Now this is equals to log r plus log e to the power I theta, which is equals to log r. R's value is what? R is equals to mod z. Okay, see here, when we will apply both the sides mod, then mod of e to the power I theta is 1 and mod of r is r itself, so r is equals to mod z. Mod z's value is how much? X root over of x square plus y square, and this is plus I theta. Okay, now here theta is what? Theta is the argument of z, arc z, which is equals to tan inverse y by x. Okay, so this is a log mod z plus I arc z. Now this is the value of log z. Okay, let us see how to find the argument. Okay, argument is denoted by theta, and for the first quadrant, see, for the first quadrant, let me denote quadrant by q. So for the first quadrant, theta is equals to alpha. Okay, and for the second quadrant, theta is equals to pi minus alpha. Alright, for the third quadrant, theta is equals to minus pi, minus of pi minus alpha. Okay, and for the fourth quadrant, theta is equals to minus alpha. Alright, where alpha is equals to, see, where alpha is equals to tan inverse mod of y by mod of x. Okay, now see here, this is x-axis, this is y-axis. Now this is the first quadrant, this is second quadrant, this is third quadrant, and this is the fourth quadrant. Okay, now here, see, this is the real axis and this is the imaginary axis. Okay, here both x and y are positive, that is, you can denote plus plus. Here means real part is negative and the imaginary part is positive. Here the real and imaginary both are negative, and here the real part is positive and imaginary part is negative. Okay, okay, so here theta is equals to alpha. Okay, and here theta is equals to pi minus alpha. Here theta is equals to minus pi plus alpha, that is minus of pi minus alpha, and here the theta is equals to minus alpha. Okay, so this is how we find the argument. Alright, now let us see an example from this. That is, here we are asked to find the value of arc minus 1 plus I. Okay, so here capital arc means, see, capital arc z is equals to theta and small arc z is equals to theta plus 2n pi I. Okay, so see here, capital arc z is equals to theta and small arc z is equals to theta plus 2n pi. Okay, so here we are asked to find the value of arc minus 1 plus I. This is z. Okay, so now let us first check in which quadrant this lies. So here x is equals to minus 1 and y is equals to 1, that is negative and positive. So it lies in quadrant 2. Okay, so here theta is equals to, say, arc z, that is equals to theta is equals to pi minus alpha. Okay, so we will find first alpha, that is equals to tan inverse mod of y by mod of x, which is equals to tan inverse y is 1 by mod of minus 1, that is equals to tan inverse 1, which is equals to pi by 4. Okay, now here theta is equals to pi minus pi by 4, which is equals to 3 pi by 4. Okay, so this is the value of arc minus 1 plus I. Okay.